All right, in this lesson, we are going to be solving quadratic inequalities. And so to start, we have to remember how to solve equations by factoring. And so for this first example, a is 1, and so we just need two numbers that multiply to 63 but add to negative 16. And so that would be 9 and 7, and they would both be negative. And so x minus 9, x minus 7 equals 0. And by the zero product property, either x minus 9 equals 0 or x minus 7 equals 0. So x equals 9 or x equals 7 would be our two solutions. On this next example, a is not 1. So first, let's set it equal to 0. So we need to move the 3. And this a value is not a GCF, and so we have to factor by grouping. A times c is negative 9, and we need two numbers that multiply to negative 9 but add to 8. That would be 9 and negative 1. So we split our middle term, bring down the minus 3, bring down the 3x squared. And then out of the first pair, we can divide out 3x, or factor out, leaving behind x plus 3. For the second pair, my first term is negative, so the GCF is automatically negative, and the only other thing that divides both is a 1. And so that leaves x plus 3. The x plus 3's match, that's one of our factors. The 3x minus 1 is the other. Still equals 0. So either x plus 3 equals 0 or 3x minus 1 equals 0. So x equals negative 3 or x equals 1/3. Okay, and so each time you solve a quadratic equation, you're finding the x-intercepts. Okay, and so for this first example, our x-intercepts are 7 and 9. For this second example, we would have negative 3 and 1/3 as our x-intercepts. Okay, solutions are the same thing as x-intercepts. And so now when we solve inequalities, we're comparing everything to y equals 0. And the y equals 0 line is the x-axis. Okay, and so when we say equals 0, we're talking about where it equals the x-axis. Equals 0 equals the x-axis. And so if we switch the equal sign to a greater than or equal to, we're talking about where it is above or equal to, so above or on. If it's just strictly greater than, we're just talking about strictly above. And then if it's less than or equal to, we're talking about below or on. And then if it's just strictly less than, it's just strictly below. Okay, and so remember your less than sign kind of looks like an L, and so I like to write the word below with the less than sign. All right, so to solve quadratic inequalities, we first have to determine whether we want any of these situations, depending on which way the inequality is facing compared to 0. And so we have to set the quadratic inequality to 0. We have to make sure we're comparing it to 0. And then we're going to find the zeros, or the x-intercepts. By factoring. And then we're going to sketch the graph and make it to where a is positive so that your parabola always opens up. And in that case, the part that's above the x-axis would be the outsides, and the part that's below the x-axis would be between the roots. So if you want to think of the greater less than thing from absolute value, it's the same idea. Okay, and so we're going to shade our interval on the number line that corresponds to the solution set, And then we're going to write our solution set in interval notation. That's going to be important for pre-cal, and so we're going to start practicing doing interval notation. All right, so first step is to factor this inequality. It's already set to 0, and so this factors to x minus 3, x plus 1, which means my roots, or my zeros, or my x-intercepts would be x equals positive 3 or x equals negative 1. So if I'm picturing my graph, my x-intercepts are negative 1 and positive 3. And so this inequality is less than, so we want strictly below. Strictly below. So that means we can't be on. So we're going to have open circles here, and then this part right here is what's below. So it's between the roots that it's below. So for my number line, I am shading between negative 1 and 3, and those are open circles. So my solution set is negative 1 to positive 3 inside parentheses. Okay, over here it's the same quadratic, and so we still have x minus 3, x plus 1. So x equals 3 and x equals negative 1 are my x-intercepts. And this time we want above or on. Above or on because of the greater than sign. So here's where we're on, and then we're above on the outsides. And so my solution set would be to the left of negative 1 and to the right of positive 3. Okay, and so to write this in interval notation, negative infinity to negative 1 with a bracket because of the closed circles, and then 3 to infinity. And so anytime you have a line underneath your inequality, you're going to have brackets in your solution set. Anytime you don't have a line, you're going to have parentheses in your solution set. Okay, and then for less than, it's always between. And for greater, you always have the outsides. As long as A is positive. That's why it's very important to make sure A is positive for your picture. Okay, and so let's look at number 4. If I set this to 0, I would have to add 8 to both sides. And this is a situation where A is not positive. It's negative 1. So my first step before I do anything else is divide the entire inequality by a negative 1, which will flip your inequality symbol. Anytime you divide by a negative, it's going to flip. Only when you divide by a negative, not just because you're dividing. Flip inequality. Okay, and so now I have positive x squared minus 2x minus 8 is greater than 0. And so now when we factor, I guess I could have written this here. Now when we factor, it factors to x. We need two numbers that multiply to negative 8 but add to negative 2. That's negative 4 and positive 2. And so my roots are 4 and negative 2. Negative 2 would be on the left, 4 would be on the right. And then now looking at our inequality, after it flipped, when we're comparing it to 0, we want above, strictly above. Okay, and then because A is 1, that's why I sketched it opening up. So strictly above is going to be the outsides, and these are going to be open circles. So open circle at negative 2, open circle at 4, and we would have the outside regions. So my solution set would be negative infinity to negative 2 with a parenthesis, union 4 to infinity. Okay, Okay, so let's look at number 5. The same situation happens. We have to add 5 to both sides, and we get negative x squared plus 4x plus 5. But then we are going to divide by a negative 1. So that we end up with a less than. We have x squared minus 4x minus 5, which factors to x minus 5, x plus 1. And so x equals 5, x equals negative 1. And then we want less than, below, strictly below. Okay, and so open circles, and then that would be the part between the roots. And so negative 1 to 5 between, and so our solution set is negative 1 to 5 in parentheses. Okay, let's look at number 3. This one is in a bad order. And so the first thing I like to do is put my x squared plus x on the left side. And then notice this symbol is facing the 6. I call it the alligator. The alligator is eating the 6. So I need to preserve that when I rewrite it. Okay, and so need to move the 6 over, so minus 6. That factors to x, two numbers that multiply to negative 6, but add to 1, negative 2, and 3. So x minus 2, x plus 3. So x equals positive 2, x equals negative 3. Remember, take the opposite of what's in those parentheses because you're setting them to 0. And so negative 3 would be here, and positive 2 would be here. And we want strictly below. Not on. So we would have open circles, and we would have the part between. So negative 3 to 2 and shade between. So my solution set would be negative 3 to 2. And so the important thing I'm pointing out is you can't just look at the original inequality. You really have to wait until you've rewritten it, compared it to 0, and have a positive a value. Wait till you've rewritten it, compared it to 0, and have a positive a value. Wait till you've rewritten it and compared it to 0 with a positive a value. Okay, and so just looking at this simple one here, all we have to do is move the 15, factor two numbers that multiply to negative 15 but add to negative 2, negative 5, positive 3. And so we don't have to do all the extra stuff I've done on the others. And so x equals 5, x equals negative 3. We have negative 3 on the left, positive 5. Make sure you're putting those in the right order. And we want above or on. Okay, and so that's to the left of negative 3 with the closed circle, or to the right of 5, the outsides. And so negative infinity to negative 3 with a bracket, union, bracket 5 to infinity. Okay, and so number 6 ends up being a special case, and then we'll talk about all the special cases down here. And so when I factor this, I need two numbers that multiply to 4, but add to 4. That's 2 and 2. And so my factor is repeated. That means I only have one solution, and it's negative 2. And so this is a graph where the vertex is sitting right on the x-axis. So you really need to draw this picture. Okay? And so that's what we're working with, only one root, 1, 0. And what we're looking for is where is this quadratic below, strictly below. Okay, and so we would have an open circle here. And if you notice, we're never below. The entire quadratic is above. And so because it's never below the x-axis, we have no solution. And so you can't shade anything on your number line. You can use the no solution symbol. That's called the empty set. In case you're wondering, empty set, it's a null symbol. And so if you use that symbol, I'll know what you mean. Okay, and so anytime you have only one solution, it's going to be a special case, but it's not always no solution. You really have to look for what you're looking for. Okay, and so looking at this example, this would factor to x plus 1, x plus 1. And so my only solution is x equals negative 1. Okay, and so negative 1 is my only x-intercept. But this time, we want below or on. Below or on. Well, we're on at negative 1, but we're never below. So our solution set just has one number, negative 1. That's it. And so you can just put it in curly brackets. It's only one number in our solution set. And if you were picturing it on the number line, we would just have a closed circle on negative 1. Okay, for number 8, this factors to x plus 3, x plus 3. These are all perfect square trinomials. So x equals negative 3 is our only solution. Okay, and what we're looking for is strictly above. Strictly above. And so we would have an open circle here, but the entire rest of the quadratic is above. And so we want every number except negative 3. So on my number line, I would have an open circle at negative 3, but I would be shaded to the right and shaded to the left. We just exclude negative 3. And so my solution set would be negative infinity to negative 3 with a parenthesis, union negative 3 to positive infinity. Okay, so here we only had 1 point in our solution. Here we were excluding 1 point from our solution set. Up here we had no solution. Okay, this last one factors to x minus 2, x minus 2. And so x equals 2 is our only solution. And then we are looking for above or on. Above or on. And so here at the 2, we're allowed to be on, so we're right there, and the entire quadratic is above. And so this would be all real numbers. On the number line, we can shade the entire thing, including the root. And so this would be all real numbers. And so in interval notation, you would write negative infinity to positive infinity. And so always above or on.